This is the multiple award-winning GardenDC podcast, the podcast about everything gardening in the Mid-Atlantic region and beyond. I'm your host, Kathy Jentz. I'm the editor of Washington Gardener magazine. Our content is aimed at gardening enthusiasts, people who grow everything from edibles to ornamentals, natives to exotics. If it grows in our area, that's what we talk about. Welcome to episode 273 of the GardenDC podcast. In this episode, we talk with Dr. Jessica Allen, lead mycologist at NatureServe, all about the world of mushrooms. The plant profile is on prairie smoke, GM triflorum, and we share what's going on in the garden, as well as some upcoming local gardening events in the What's New segment. We close out with the last word on the Unwritten Garden Journal from Christy Page of Greenprints. What is my personal favorite fungi? Be sure to listen to the end of the episode to learn about that. This episode, we're joined by Jessica Allen. She's a PhD and lead mycologist at NatureServe. Welcome, Jessie.
Hi, Kathy. Thank you so much for having me.
Thanks for coming on, and we're going to talk about all things mushroom, fungi, all that good stuff. Before we dive into all that, we like to ask our guests here on the GardenDC podcast, were they born with chlorophyll in their veins and a green thumb?
Oh, man. I would say yes. I come from a family of gardeners and farmers, and growing plants is definitely core to what I do, what we all do. And I recently moved to San Diego from Washington State, and it's been a pretty fun new adventure in gardening down here.
I bet. So you were a lifelong gardener or surrounded by gardeners. What made you interested in fungi?
Yeah, I went to college to study music, despite kind of being immersed in the natural world so intensely through my growing up times. And I actually quickly switched to studying conservation biology. And then in my undergraduate biology, like introductory biology course, that year-long course most students take, the only chapter we skipped was on fungi. And so I went back and read it, and it just blew my mind, and I was hooked. I thought they were the most interesting organisms. I was so curious about them. They were this entire kingdom of life that we're all surrounded by all the time, and I just hadn't understood them or appreciated them. And I was then lucky enough to be at a school with a great mycologist, a great fungal biology teacher, and was able to then move into taking courses on fungi, studying fungi, and have been lucky enough almost 20 years later that to have continued that work.
And you said you moved recently from Washington State to San Diego. I'm imagining the amount of mushrooms and fungi in Washington State is pretty high up the scale. Uh-huh. And that San Diego, Mediterranean kind of climate, right? Mm-hmm. Not so much.
Yeah, it's very different mycologically, that is for sure. Certainly the Pacific Northwest, for the diversity and sheer biomass of mushrooms and mushroom-like fungi is really, it's just incredible. If there's anybody who's listening who's never gone mushrooming in the Pacific Northwest and is even a little bit curious, you should do it. It is just a mind-blowing experience. But I will say that there are mushrooms in San Diego too. It's just very, like mushrooms tend to be, that's just very rain dependent and when they fruit. And so it's just depends on the year, depends on the week. I'm sitting here right now and it's actually raining, which is incredible. And to me, I said, when this happens, I say, okay, a few days from now, a week from now, we have the potential to have like an incredible mushroom emergence, and I should mark my calendar and get out there. And this year, with the few rains that we've had, it's like we have had some really remarkable mushrooming moments. But mushrooms are not the only fungi that we can encounter pretty readily. The group of fungi that I specialize most in are lichens, which are symbioses between fungi and algae, and they are not seasonal. They are always there. And if you've ever noticed these sort of light green patches on your trees or rocks or in the ground, or those are probably lichens if that's what you're seeing. And lichens are everywhere, and they are incredibly diverse here in San Diego County. So even if the mushrooms come and go and they're very seasonal, my main love in mycology is always there to be seen.
That sounds wonderful. And I'm going to be in Portland this summer, so I'm definitely looking forward to some mushroom excursions there. And in past episodes of this podcast, we've shared about lichen and foraging in the mid-Atlantic and some about our native mycology. And you work remotely for NatureServe, which is based here in the DC area in Arlington. Let's talk a little bit about NatureServe and who they are and what they do.
Yeah, NatureServe holds the authoritative data on at-risk species and ecosystems in the United States and Canada. They're really the hub of the Natural Heritage Program network. So we work across the continent and coordinate and support organizations that are really focused within each state and province on the natural biodiversity there. So we're kind of the hub of this 60 organization network. And it's been really exciting to join NatureServe as a mycologist, as their first mycologist, because fungi have often been overlooked in conservation for a lot of reasons, but that's changed. That's changing. And there's a need across the continent to better understand these organisms, to better understand how to conserve them, and to kind of look for that support and some really catalyzing some action around fungal conservation. And so it's been incredible to join this organization that's been around for 50 years and has done such incredible work with animals, plants, and ecosystems. And now we're adding another kingdom into the work that they do.
And so let's explore that kingdom. So what makes fungi different from plants, from the plant kingdom?
Yeah, so fungi are, well, let's just start with defining fungi, right? So fungi are, they're eukaryotic organisms. Okay, so they're not, that just means they're not bacteria. They are what we call heterotrophic organisms. That means that they get their nutrition from breaking down organic matter from other organisms. So unlike plants that are, doing that kind of magic of photosynthesis and building sugars themselves, fungi cannot do that. They do not photosynthesize. They acquire their nutrition by breaking down organic matter and absorbing the nutrients that are released from that. And fungi are actually much more closely related to animals than they are to plants. And we can see some parallels there in that mode of digestion. Also, fungi are multicellular organisms for the most part. So they're not like, other protein. They're not like protists that might be unicellular. They are multicellular. They do form complex structures, and they have cell walls. So animals do not have cell walls. Plants do have cell walls, but the cell walls of fungi are made out of chitin, and the cell walls of plants are primarily made of cellulose. We do see chitin in the animal kingdom, so the exoskeleton of insects is made of chitin as well. It's a slightly different form of chitin than the one that fungi make, but it's still like fundamentally the same compound.
Interesting. And I was thinking about carnivorous plants. We did an episode not too long ago on them and how they get their nutrients from the breakdown of organic matter of other living things too.
Yeah, for sure. There are parasitic plants, hemiparasitic plants, so they haven't given up on photosynthesis, but they do draw some nutrients, often from other plants, or even like mycoheterotrophic plants like ghost pipe, which has completely lost its chlorophyll, still a plant, but is really getting its nutrients by tapping into fungi, which I think is pretty incredible.
Yeah, ghost pipes are pretty cool. And then the other major difference, of course, with fungi in between the plants and animal kingdom is how they reproduce.
Yes, definitely. So they reproduce and disperse through spores, and those spores can be the product of sexual reproduction or asexual reproduction. And then fungi also reproduce clonally by fragmentation as well. If you think of something more like a succulent, and some fungi make really special structures to reproduce primarily in that way. So there's a whole spectrum of reproduction. And of course, mosses and ferns also make spores. And really, what spores are single cells or sometimes a couple of cells that are competent in and of themselves to disperse and grow into another mature individual without having to merge with another cell. So they're not an egg or a sperm or pollen or something like this that are produced that and then have to go, encounter another cell to complete reproduction. They're like competent in and of themselves.
So kind of like what you're saying with succulents, where you have an offset, like mom and hens and chicks, the little babies of that type of succulent. But also I'm thinking of a hosta plant where you can divide and each of them can survive on their own as long as they have a little bit of root with them.
Yeah. Clonal reproduction or fragmentation, it's like a very powerful way to reproduce and to survive in a lot of ways. It's kind of interesting just because evolutionary biologists, we there's a lot of theory around asexual reproduction being an evolutionary dead end, and kind of reducing the adaptive potential of species. But at least in plants and fungi, we see so much clonal reproduction. And actually, there are fungi that we've never observed sexual reproduction happening. So it's not even that it's that the clonal reproduction is one of many modes of reproduction. It seems to be that at least some fungi have gone completely all in on clonal reproduction.
I'm thinking about the human race now, Jesse. I was like, one day that might be us too. That's a very interesting theory too, that they think that's the end of evolutionary. But I'm like, I think that's actually the next step. Why would you need to do anything if you think you've gotten to perfection? Why do you need to combine cells with somebody else or some other organism? Yeah.
I mean, it's such a funny perspective on it, but you really do get to the heart of the matter. And I think that it's particularly interesting because we see this in lichens, and of course these are these obligate mutualistic symbioses, so fungi and algae that have to live together for lichens to exist. And the trade-off there for sexual versus asexual reproduction, like the math of that really changes, because if the fungus and algae, they find the really like that perfect partner, it just seems so much more beneficial for them to stay together, versus when the fungus reproduces sexually, usually that means the fungal spores go out and often end up with a different alga. And so there's a reshuffling of the symbiosis. So you can kind of think of the pros and cons in both directions, but one of the major pros for that clonal asexual reproduction is that, okay, we found the perfect partner, so let's just keep doing this, right?
Yeah, I think we can talk about that all day long. And I'm like,
There are a lot of directions to go.
There's a lot of directions we could go in there. We'll just let the listeners' mind wander there.
Yes.
And how about we talk about how many types of fungi exist? So I know that there's a vast amount maybe that haven't been even documented.
Yeah, so there are around 155,000 named species of fungi that have been discovered and gone through the formal naming process. And we estimate that there are likely at least 2.5 million species. Some estimates are up to 5 million species. So we've really just started to scratch the surface in our understanding of fungal diversity and really the diversity in this kingdom of life. And to me, that is really exciting because there's still so much left to discover, and that fungi are, at least from my own experience as a taxonomist and really studying fungal biodiversity, it's just such a joy, and it's so exciting to find new species and to really live in that place of wonder and awe at the massive amount that we don't know about biodiversity. So there are those 155,000 species that we have named that we do know a lot about. There are a lot of species we have a great depth of knowledge about, and there's still so much left to discover.
So if you want job security, I'm hearing that mycology is the way to go.
I mean, at least an truly endless task that would take multiple lifetimes. Just cataloging fungal biodiversity would certainly, there would be no endpoint. There is no endpoint to that, at least on the near horizon.
And then why do you think, Jesse, that this has been the most unexplored or overlooked kingdom, the fungi kingdom?
Yeah, so in a conservation context, I think there are a lot of reasons that fungi have been, tended to be overlooked. And one of them is that there are fungi that are pathogenic. There are especially invasive pathogenic fungi that have had devastating impacts on ecosystems. I mean, the eastern deciduous forest is one example of that, with chestnut blight, for instance, and repeated different fungal pathogens invading. There are fungal pathogens of crop plants and, of course, in your gardens, in all of our gardens. And so I think there's one aspect of working in mycology that is really that there are some really serious pathogens out there that it can be very hard to control. So as far as negative impacts on ecosystems, the other element I would say is that the advent of fast and easy and inexpensive DNA sequencing has unlocked our knowledge of this group of organisms and let us access them in a way that we never have been able to before. So especially in thinking about soil dwelling or underground communities, being able to take a sample of soil and sequence everything that's in there has opened our eyes so much to the diversity of fungi, to their contributions to ecosystems, to that positive impact, to even a greater understanding of just how much carbon they sequester. It's absolutely incredible. And so I think these new technologies, DNA sequencing being one of them, there's some really incredible advances in microscopy as well that have been helpful in better understanding fungi and what they do. But I think that we've just been able to understand them in a way we never have been able to before. And then finally, I would say that the mycological community of both scientists and enthusiasts, or we could say amateurs, have done so much for communicating about fungi, and that communication and all of that work has paid off in a big way, in that we've had such a major public shift in the perception of fungi.
Yeah, I think mushrooms are in. I'm just going to say it that way.
That's a good way to, yeah. Uh-huh. And I'm here. I love it.
Yeah, I love a mushroom print on, I see people, from everything from shower curtains to purses. You see the gorgeous, kind of old-fashioned, almost Victorian-looking mushroom artwork that people love to collect. And I definitely think that's, part of the 21st century kind of geist that we love that. Yeah. We love some of those little cute things. First of all, they're cute. A lot of times what we're seeing, of course, above the surface is something cute and little. And, the red ones with the dots, the brown ones with the curve. And so they're almost collectible like that. But I also think what you're saying about the plant community, and especially I'm thinking of my orchid collecting friends, that connection with the mycorrhizal fungi is so much new is being learned every day, and unlocking these secrets to growing orchids that we just didn't know. We just thought, I remember, decades ago, people would say, you have to dig the soil that the orchid was growing in or it's not going to grow. But you didn't know why. But now we know why. It's because the native mycorrhizae are in that soil and it has to come along with that plant.
Yep, absolutely. Orchids are such, they're what an incredible plant and an incredible symbiosis, right? It's, there's still so much we don't understand about the orchid mycorrhizae, but it's true. There's been a ton of advancement there, and it's, it's so. There's so many places we could go in talking about orchids. One thing I would share though, before I kind of opine on the orchid mycorrhizal symbiosis is just, like you said, mushrooms are in. And I just have to say that when I took mycology, that was almost 20 years ago now, there were 5 people in the class, and I had so many, I would say family members were interested, maybe concerned about this. And now, before coming to NatureServe, I spent quite a few years as a professor, and when I would teach mycology, the class would fill and there would be a wait list, and it's just so exciting, right? That this massive shift is happening.
I was going to say, I can imagine maybe at a cocktail party type situation, and now you say you're a mycologist, people are super interested, right?
Yeah. Absolutely. They're like, oh, great, I have questions for you, instead of being like, oh my. Anyways. But yeah, orchids are such an interesting one, and especially, and these aren't fungi that I have spent a lot of time personally studying, but in that the plant, like you said, in like the plant world and in the plant conservation world, it's pretty incredible the advancements that have been made, and even just understanding like seed germination for orchids, their persistence, like how to actually grow them in a garden in a controlled setting, and then also how to support native populations and how those dynamics work around orchids. Of course, like they don't necessarily flower every year, and what part do the mycorrhizae have to play in that? So but I feel like that is like a whole nother episode.
Yeah, it's so incredible and so interesting. And I hope, in a decade from now or 2 decades that we'll have a lot of those mysteries unlocked for us. It'll be so interesting to learn more about that. So back to fungi in general. So mushrooms are fungi, but not all fungi are mushrooms, correct?
That is correct. So most fungi are actually microscopic. They don't form any structure that you generally can see with your naked eye. So they're growing in the soil or in water, or they're things like molds on the bread in your kitchen, or they're yeasts that make alcoholic beverages or bread that we eat. So most of the diversity of fungi are microscopic, and then some fungi form these macroscopic, what we call fruiting bodies generally. And that term fruiting bodies applies to any of those structures that produce spores. Some of those are mushrooms and mushroom shaped with your like nice cap and stalk, but some of them aren't. So if you think about like shelf fungi that might be growing on rotting wood or dead wood, things like turkey tail, right? So those are fruiting bodies. They don't kind of fit that typical mushroom mold. Or you could even think about things that are more even like kind of crusty looking, again on rotting wood. So there are a lot of different shapes that mushrooms can take. I would also point out like stinkhorn is a fruiting body, or truffles that we like, culinary truffles they form underground, and they're really kind of this lumpy ball shaped structure. So not a mushroom looking structure, but certainly a fruiting body. So that's kind of our big picture umbrella to try to encompass the really like incredible diversity of forms that macroscopic fungal fruiting bodies can take.
I'm a big fan of truffles, and I always thought of them as kind of like a starch or a tuber, like the thing you would find along a root zone. So it's really interesting to me.
Yeah, they do. They can kind of look like a weird little potato sort of thing. And of course they're underground. So yeah, I see you like that. Kind of, they're similar in that way. And when you cut a truffle open or kind of you look at that picture, you see this sort of like maze-like structures inside, these interesting patterns and textures. And so what's happening there is that's where the spores are produced. And it's instead of having spores produced on like the gills on the underside of a mushroom cap, they're inside there. And truffles, one of the reasons we love them is they produce all of these like volatile compounds that smell so good and they taste so good. Or, I mean, some people really don't like truffles. I mean, they're just pungent, right? They're
Yes.
they're very bold flavor. And part of the reason for that evolutionarily is that attracts animals to dig them up and eat them. And that's how the spores are dispersed.
Fascinating.
So rather than like a mushroom, for like a true mushroom where spores are on the gills and they're forcibly discharged and they get blown away by the wind, these with truffles, they're actually dispersed by animals.
So there's that symbiotic relationship with animals.
Absolutely.
It's interesting. And I always think of one of my favorite effects of mushrooms blooming in a fairy ring. So maybe after a spring storm, a couple of days later, you'll see a fairy ring or maybe a half fairy ring pop up in your garden.
Yeah, so a fairy ring, besides being delightful to see, what's happening underground is that the main part of the fungus, so those are what we call, that's what we call the mycelium, and the mycelium are like aggregates or grouped together of hyphae. And so hyphae are really the fundamental building blocks of fungi. They're strings of cells or filaments of cells. And so if we think about those kind of, think about a very, very thin strings, they then grow in clumps or grow wrapped around each other, grow together in high density. That's the mycelium. So if you've ever flipped over a log and you've seen that white mass and like the filaments of these growing there, that's the mycelium. And when you see a fairy ring, that is happening, but it's happening underground. And the fungus is really growing out in kind of a circular shape or a half circle. And then at the edge of where it's growing, when the conditions are right, it produces those mushrooms. And then you're seeing really what's fundamentally a very small part of the fungus, because most of it is underground. And that can happen year after year. So if you're not spraying your yard with fungicides or something like this, what you probably will notice is that ring will keep growing out. You might have a zone of kind of dead grass where the fungus is really pulling in a lot of nutrients, and it just keeps growing out and out from there.
Yeah, and I hear so many myths about fairy rings that it means that there's decaying wood underground or that there's disease. Could you dispel some of those?
Yeah, so the ones you often see in the yard, well, I mean, I can't dispel the myths about fairies. I don't know about that. But as far as these fungi pathogenic or something to be concerned about, a lot of the species that grow as fairy rings in the yard are decomposers. They're what we call saprotrophs. They're primarily breaking down dead organic matter, and that they're not problematic. They aren't concerning. There are some that you could see in forests that are pathogenic or parasitic that can grow in a similar way. Often, like wood pathogens, or at least weak pathogens, partially breaking down decomposed wood, partially breaking, maybe infecting living trees. It's kind of across the whole spectrum. But usually if it's in your yard, it's not, if it's just in your grass, it's not something to be concerned about necessarily.
Because I'll see people go around and kick them down, or kick the mushrooms, or I mean, they're helping to spread the spores kind of that way, but
Yeah.
I don't think it's a necessary task in your garden.
No, especially the mushrooms, if you remove the mushrooms, it does, that gets the mushrooms out of there. If you can't identify the species confidently, some of these small brown mushrooms are poisonous. So if you have pets or kids, you might want to do that. But that fungus is still alive underground, and removing those mushrooms isn't going to harm it.
GardenDC will be back after this short break.
Get low-maintenance alternatives to lawns with Ground Cover Revolution by Kathy Jentz. Reducing the lawn is among the biggest trends in homeownership, with an endless stream of homeowners looking for an eco-friendly alternative to a traditional turfgrass lawn. In the last few years alone, over 23 million Americans converted part of the lawn to a natural landscape, and now they're looking to do even more. The biggest challenge to adopting this new ideal of the perfect lawn? Knowing how and when to replace your turf and which plants are the best ones for the job. Ground Cover Revolution is here with all the answers you need, and some you didn't even know you needed. Included are 40 in-depth profiles of plants that are perfect choices for replacing a grass lawn. There are options for sun, for shade, for dry and wet sites, and for various climates around the globe. There are choices that bloom, options that are evergreen, and selections that are deer-resistant. Kathy Jentz has also included an incredibly useful chart that gives you all the specifics on each of the 40 choices for quick reference and to make your ground cover selection process even easier. Whether you want to replace the entire lawn or just reduce the amount of land dedicated to turf, Ground Cover Revolution will help you usher in a new and improved idea of what a beautiful lawn should be. Ground Cover Revolution is available now wherever you buy books, including Amazon.com and Bookshop.org.
So the roles that fungi play, we talked about the decomposition, and they are also known as master chemists. Can you talk about that a little bit?
Yeah, so in the environment, fungi play a lot of different roles. I'd say another theme that always comes up with fungi are the connections. So they're in symbiotic relationships with orchids or with algae or sometimes pathogens or parasites. And, in addition to decomposing dead organic matter and being primarily recyclers in forests or living as mycorrhizae, they really do perform many different ecosystem services. I would say carbon sequestration is a major one of those. But in thinking through all of the different roles that fungi play in thinking about how they grow as hyphae or mycelium, in how they interact with other organisms and with other fungi, a lot of what they do is mediated by chemistry. And what I really mean by that is that fungi produce thousands of compounds that no other organisms make, and they're synthesizing them inside of their cells, and then generally they secrete them or they push them to the outside of the cells. And what the fungi are using those for is as compounds to either compete in the environment, to break down the food that they're then going to absorb, to communicate with plants and algae, to, in some cases, they're fungi that break down rocks even. So you're building these really strong acids or communicating with each other and we could, just to really anthropomorphize the fungi, really communicating with each other to send messages about okay, we might be suitable mating partners or things like this. And so fungi make pheromone receptors, etc. And through because they kind of mediate a lot of interactions and a lot of what they do in the environment through chemicals, they've evolved to have this like wealth of compounds that we can pull from them. And many fungi, if not most, make slightly different suites of chemical compounds. And so we as humans have harnessed the power of fungal chemistry in a lot of different ways. And the most famous fungal compound, I would say, is penicillin. This is, of course, like a breakthrough antibiotic that has saved untold numbers of lives over many years that it's been in use. And many other antibiotics are derived from fungi. And we have other examples of drugs like statins, for instance, are from fungi. And I think this is where it really kind of speaks to that close relationship between fungi and animals, and that we can also benefit a lot from their chemistry.
Yeah, I think with so many undiscovered, as we were talking about, the 2 million on up, there's so much out there that might be able to help cure diseases, assist humans, but also just so much unknown.
Absolutely. And that's one of the primary motivators for conserving fungi, is that if we're really, if we're going to be like very, very focused on what might fungi do to benefit me as an individual, conserving them, making sure they don't go extinct is a crucial part of that. Because, right, as you pointed out, Kathy, it's like we only know of 155,000 species. We've only characterized the compounds made by a subset of those. But what about the rest of the species out there that we haven't even studied yet, that we haven't even looked at their chemistry or described them or anything like this? So I think it's really crucial that we conserve the species that we do know exist, and that we continue to study fungi and continue to build out our conservation practices to make sure that we lose as few of those species as possible. Because we don't know, you just never know when we might lose the species that had that next life-saving drug. And so it's part of why it's really exciting to be here with NatureServe and to be pushing on that and really trying to move the dial on that.
And how do you conserve fungi? Like, it's not like you're going to collect them, right? And
yeah.
Is it trying to preserve the spots that they occur in and keep them natural?
Yeah, absolutely. So what we'd call like in situ conservation, understanding where rare species are, and then making sure that we prioritize conserving those spaces is a huge part of it, definitely. And there's one step that happens, well, there's a couple steps that even happen before that. One step is that this part of describing species and then studying where they occur, trying to figure out where are they actually, which sounds very simple, but it's actually can take an immense amount of work, but it's part of why platforms like iNaturalist are so powerful, where people can upload their observations of fungi and really contribute to that knowledge about where species exist. And then a lot of what we do at NatureServe is to take the information that we know about those species and look at and gather all of our knowledge about the species, and then we figure out essentially which ones are at risk of extinction and which ones are not. And then once we have that list of species that we say, okay, these are of concern, maybe they have restricted distributions, there are clear threats to them, we're concerned about these ones potentially going extinct, then we can prioritize using resources to save those species. So it might be things like prioritizing land acquisition, but it can also be things like, wow, there's a really critically endangered species at this site and it's in a mixed use forest or something like this, and say, well, maybe we shouldn't log at this place and we should prioritize those types of uses somewhere else. So there are a lot of different ways this can look like. It is also, of course, not for all fungi, but for some fungi, they are culturable. And so we can actually bring them into conservation culture collections and preserve them in that way. So you could think of this as like an analog to a seed bank, or to some of these like living collections that you see in botanical gardens.
Okay, so you could do, your kind of herbarium, but I don't know what it would be called, fungarium.
Yeah, that is what it's called. Exactly.
Just guessing there. And then at least, in little vials or, keeping the spores alive and maybe be able to propagate them from that eventually. So, but some of those landowners, I'm imagining you go and you tell them, well, you have a rare mycelium fungi on your property. Can you not do this there? I'm going to guess that is kind of a hard argument sometimes to make.
Yeah, it can definitely be, it can be challenging. I would say I also find a lot of encouragement in this space because the understanding of how crucial fungi are to functioning ecosystems has become so widely accepted that it's not as hard of a conversation as you would think, and that I've actually found that a lot of land managers across private and public lands are actually just really curious. They say, "Wow, I've learned that fungi are so crucial, and what can I do and to preserve them, and which rare species might occur here, and I even things like." This is an important bird area, and we know that birds, especially hummingbirds, use lichens in their nests. And so what can we do to make sure that the lichens or the other fungi can thrive here as well? So I'd say that has changed a lot, and I'm incredibly encouraged. I think there's a huge amount of will and interest there.
That's such great news to hear that, and that the message is getting out to the public, because in conservation, especially with rare plants, it's always been that if it doesn't have eyeballs, it's really hard to get people to care about it, right? So they're what we call green blindness. I guess we could call this fungi blindness or something similar, I'm sure, in mycology. But if it doesn't, have those big eyes looking back at you, like the panda or a tiger or something else, and be a charismatic animal, it's really hard to convince the public that it's important to conserve it.
Yeah, that absolutely, Kathy. That bias still exists very strongly, and we can see it in the conservation spending, like funding allocation, which is a lot of what moves action. It very much exists still, and in that public perception. I will say I have not been above photoshopping some very cute eyes onto some fungi, and to get this point across. But I feel like the trajectory is overall positive, and I continue to be hopeful that we keep it on in this direction.
And as we said, mushrooms are now in, and I think a lot more public interest, in the entire kingdom is out there. So I think there will be a continuing, hopefully, assistance for your work. And so if listeners want to contact you and find out more, how can they reach out to you, Jessie?
Yeah, so I am on Instagram. I think that's probably the easiest place. And my handle is jallen.lichenology. That would be the best place to find me.
Okay. And to reach NatureServe, we'll put the link for their website in the show notes, but it's pretty easy. It's just NatureServe with the E at the end .org. So nature and then serve as in service.org.
And you can find us on all the social media platforms, and we share a lot of good news about all the different groups of organisms and the work that's happening across the U.S. and Canada.
Well, let's sum up maybe by talking about our favorite fungi. So I'm going to let you just hear the one that you just adore.
I love bird's nest fungi. These are in the order Nigellariales, and they are wood decomposers, and they're quite small, and they are one of these fungi that is just like so adorable, so like really kind of magical. They start by forming these sort of small ball-like structures, and then the top of that eventually comes off, and then it really looks like a bird's nest. So the outside, there's this like nest-like structure, and then inside, the spores are in these little packets called peridioles, and when they're in there and that kind of the nest part is intact, it truly looks like the most miniature, adorable bird's nest. And it's also really cool because the shape of that nest part, it's like a little cup, is such that when like a raindrop or water droplet hits it just right, the packets of spores are launched out of it and they go flying. So I love those so much. How about you, Kathy?
I was going to say, those are so cute. I love seeing them pop up. They're maybe the size of a nickel or a quarter.
Yeah.
Usually it'll be in the wood chip mulch around our community garden. I might see it. If you look close enough, it is so adorable. I'm going to save my favorite fungi for the end of this episode, Jessie. So listeners will have to listen to all the way to the end, and I'll share that. And I'll give you the last word about why fungi are important.
Even though we often overlook fungi, or we might not love that they're molding over our bread, they're incredibly important for the health of our planet, the health of our ecosystems, and the health of humans. We really rely on them for holding carbon, for providing a unique source of compounds that we can use industrial and pharmaceutically, and for sustaining plant and animal life. So what I would really encourage listeners to do is just have a fungus appreciation moment or two in the coming weeks. And when you're out in your garden or you're out hiking, just take a minute and look for the fungi. In the winter, you might mostly be seeing lichens, but just take that moment to look at them. And I always encourage people to look closer, because that's, to me, where the real magic happens. So if you have a small hand lens, that's just like text magnification, to stop, take a closer look, really take in what the fungi have to offer to us.
Excellent. Thank you so much, Jessie.
Thank you, Kathy.
GardenDC will be back after this short break.
In the book The Urban Garden by Kathy Jentz and Terry Spate, you'll find dozens of inspiring and creative ways to grow flowers, shrubs, vegetables, herbs, and other plants in small spaces and with a limited budget. Whether you want to grow on a balcony, rooftop, front stoop, or a tiny urban patio, turn your growing dreams into reality and build a gorgeous and unique garden that showcases your personal style while still being functional and productive. With the genius ideas and resourceful tactics found here, you'll be maximizing yields and beauty from every square inch of your space. No matter what you grow, the 101 amazing growing ideas found in the urban garden will turn your tiny urban yard into a treasure trove of green you'll be proud to share with family and friends. Buy your copy today at your local retail bookseller or order it online now at Amazon.com or bookshop.org.
Prairie smoke plant profile. Prairie smoke, Geum triflorum, is an herbaceous perennial with reddish-pink flowers that turn into charming, wispy-looking seed heads. The foliage is ferny and a bit similar to that of a wild poppy. It's also known as old man's whiskers, purple or red avens, lion's beard, grandfather's beard, and three-flowered avens. It's native to southern Canada and the central and northern United States. Somewhat surprisingly, this prairie wildflower is in the rose family. It's hardy to USDA zones 3 to 7. Prairie smoke blooms in late spring into early summer. The flowers are held together so tightly that the bees have to force their way in to pollinate them. It does best in a well-drained site in full sun. Prairie smoke is only about a foot tall, so plant it in the front of flower beds or in rock gardens. Prairie smoke can be sown from seed. First, the seed should be cold stratified for 4 to 6 weeks. and then started inside in late winter, then planted outside in May. It can also be propagated by division after it finishes flowering or in the fall. Prairie smoke is low maintenance, pest-free, and deer-resistant. Prairie smoke, you can grow that. What's new in the garden this week? Well, we're still waiting for the snow and ice to thaw, so inside I'm enjoying the blooms of the tulip bouquets from Quince Blossom Ridge Flower Farm. In the garden tips that we shared on our social media this week, we talked all about cut flower care, including that if you are out of commercial flower food, you can add a pinch of ground up Viagra to help your flowers last longer. Other additives for longer lasting flowers include aspirin, sugar, citric acid, and alum powder. In local gardening events, the Galanthus Gala is coming up on Friday, February 27th and Saturday, February 28th in Pennsylvania. This gala centers on all things snowdrops, and it's hosted by friend of the podcast, David Culp. You can register for it at Brandywine Cottage's website, and it includes several expert speakers. And in addition, there will be top-notch vendors with collector's plants, including those prized snowdrops, but lots of other great plant selections. So check that out. That same weekend is also the start of the 2026 Philadelphia Flower Show in Philadelphia, Pennsylvania, at the Pennsylvania Convention Center. That runs February 28th through March 8th. This year's theme is Rooted Origins of American Gardening. They have breathtaking gardens, international floristry, hands-on workshops, family-friendly fun, and of course those signature after-hour events. This is the 197th year of the show. The award-winning flower show is the nation's largest and the world's longest-running horticultural event. It serves as the Pennsylvania Horticultural Society's main fundraiser. For the latest information and details and to register for the flower show, go to phsonline.org. And then closer to home at Green Spring Gardens in Alexandria, Virginia, on Saturday, March 14th from 12 noon to 2 p.m. is the Plant Swap, Houseplants, Cuttings, and Containers. Bring your unwanted houseplants, cuttings, and containers to swap with others or simply give away. Leave with new plants, containers, and garden friends and expert advice. Registration is encouraged. This is a free event, and you can find out more details and register online at fairfaxcounty.gov/parks/parktakes. Happy gardening!
This is The Last Word by Christy Page at Greenprints on the Unwritten Garden Journal, a story by J.C. Hall. Garden journaling is best left to gardeners who are far more methodical than I am. I'm sure the meticulous records they keep serve some practical purpose, but I can't imagine how I'd use them. Sure, I forget where I've planted bulbs. Who doesn't? And yes, I lose track of color schemes and plant pairings. Should I map out a master garden plan? Perhaps. Would it help if I labeled plants in both the ground and my non-existent journal? Almost certainly. But let's be honest, I'm not that kind of gardener. I prefer to rely on luck, whimsy, and the sheer delight of surprise. Forgotten bulbs poking through the soil, a gift from my past self. Plants haphazardly growing together in unexpected harmony, a stroke of good fortune. My garden philosophy is simple. Happiness is finding joy in the way the garden grows, not in how it's planned. I don't crave the precision of straight rows or the rigidity of manicured lawns. Instead, I lean into the charm of chaos. Long grasses swaying over hard edges, pots overflowing with greenery, and bushes left untamed to grow however the sun and soil dictate. My suburban lot, hemmed in by neighbors, fences, and city codes, is a controlled wilderness. From the outside, mature trees and untrimmed bushes obscure my home, but from inside, my Eckler-designed sanctuary, floor-to-ceiling windows transform every room into a viewing gallery of my garden's wonders. The garden isn't just outside, it's an integral part of my living space. Birds flit among the bushes just inches from the glass, while the light dances through leaves, illuminating my rooms with ever-changing shadows. If I were to keep a garden journal, its pages would overflow with stories of wildlife. Which berry-laden bushes attract migrating birds? Which flowers draw bees, butterflies, and hummingbirds? I document nest builds, spiders spinning webs, and the awe-inspiring comings and goings of life. But honestly, who has time for all that? I'd rather immerse myself in the unfolding drama than write it down. The garden, after all, is a world unto itself, too vast and alive to be contained within the pages of any journal. This has been The Last Words by Christy Page at greenprints.com.
Thank you for listening to GardenDC. This episode was made by Real Humans. It was produced and hosted by myself, Kathy Jentz. The Let the Sunshine music interludes are by James Mulvaney. If you like this episode, you may also enjoy listening to GardenDC Podcast Episode 220, The Age of Lichens, Episode 132, Moss Gardening, Episode 219, Native Ferns, Episode 37, Foraging. You can become a listener supporter by going to the link in our show notes. Another way to support this podcast is to subscribe to our monthly digital publication, Washington Gardener Magazine. To do so, go to WashingtonGardener.com or WashingtonGardener.blogspot.com. You can find Washington Gardener on Twitter or X, Instagram, Threads, Blue Sky, and Pinterest at WDC Gardener, and on Facebook at Washington Gardener Magazine. And be sure to leave us a 5-star review on your favorite podcast listening app. Please take a moment to share us on social media with hashtag GardenDC and with your gardening friends so other gardeners can find us too. My favorite fungi is lion's mane. It's white, edible, spine-covered mushroom found on trees. It has a cute, fluffy, white pom-pom appearance that makes it look almost petable. It's a species of tooth fungus. It's native to North America and Eurasia. And according to Wikipedia, the mushrooms are common during late summer and autumn on hardwoods, particularly American beech and maple. It's an edible mushroom and used in traditional Chinese medicine.